This video is going to show you how to make calibration solutions. So if this is something that you're struggling with, hopefully it helps. So the scenario that I've got here, I need to make up calibration solutions for copper, and the calibration solutions I need to make up are here. So the stock solution that I'm given is 1,000 milligrams per litre, and that's its unit of concentration, and I'm going to be given 7 volumetric flasks that have volume of 100 millilitres each. So I think the first thing to bear in mind really is the difference in the units, because as you can see, the calibration solutions, the concentration for those is micrograms per litre, but for the stock solution it's milligrams per litre. So it's just something to account for later on. And also the concentration of the stock solution actually only relates to the copper. So I think the first thing you need to do is really establish the relationship between both units of concentration. So 1 milligram per litre is equal to 1,000 micrograms per litre. And what I've done is I've constructed a table just to show you its equivalent in the other units. So I've put in the left hand side the calibration solutions that we were given and the concentration at the top, and then I've done it in milligrams per litre. So basically it's equivalent. The reason why I've done this is just because our stock solution is given in milligrams per litre, so I feel like it will be easier to work from that. So the procedure would be in the lab script, but just as a reminder, you need to label one volumetric flask. For instance, you could just call it A1, and then you're going to take 1 milliliter out of the stock solution using the pipette, and you're going to place this into a volumetric flask, and you're going to make it up to the mark with deionized water. So basically, in numerical terms, what you've done is you've done 1,000 times 1 divided by 100. And just a description of what this actually means, the 1,000 milligrams per litre is the concentration of the stock solution. The 1 milliliter is the volume that you're taking out of the stock solution, and the 100 milliliters is the volume of the volumetric flask that you're using, so A1. When you work this out, you are left with 10 milligrams per litre. Now, this new flask called A1, obviously that's not its actual name, so the actual name of it is it's called the intermediate standard. And just to give you a brief explanation of how it works, because sometimes people get volume and concentration mixed up. So when you take that 1 milliliter originally out of the stock solution, inside it, within it, the concentration is still 1,000 milligrams per litre, because like you haven't done anything to it. But then as soon as you put it inside the volumetric flask and you dilute it, that's when a totally new concentration is made up. As you can see here, this is our intermediate standard. So again, just an explanation of why it has units of concentration. Just like how you have like normal fractions, you just cancel out the top and the bottom of the units of volume. So basically you're just left with units of concentration. So you have a 10 milligram per litre intermediate standard. The reason why I've put the table from before in is just so you can compare. So it's just a reminder really of where you're trying to get to. As you can see, 10 milligrams per litre and 0.1 milligrams per litre, there's still like a big range between them. So your best bet is just to keep diluting your intermediate standard. So for trial and error purposes, what I've done is I've just taken 2 milliliters this time. So you can put aside your stock solution. You're going to start working from your concentration of intermediate standard. So you've got 10 times 2 divided by 100, and as you can see the labels, it tells you exactly what each one means. So this is going to equal 0.2 milligrams per litre. Now, as you can see, 0.2 milligrams per litre is not too far off from 0.1. So that basically means that you're just going to have to do some adjusting really. So if 2 milliliters gives me 0.2 milligrams per litre, then that means that 1 milliliter must give me 0.1 milligrams per litre. So what I've done here, basically, I've just done a fill in the blank table, and you can just really see the trend that's going on. So the milliliter, you just need to divide by 10 to give you the milligram per litre. So the question marks are just fill in the blanks really, in case you wanted to have a go. And on the right hand side, this is basically just the complete table that's full. So I hope this has helped.